Welcome, my friends. Consider the functions f of x is equal to x squared plus 1 and g of x is equal to the square root of x plus 6. Let's say we want to find f of g of 3. This is just a fancy way of writing that we want to find f of g of 3. Or in other words, working from the inside out, we need to evaluate function g at the value 3 and then use whatever that output is as the input into function f. The first step is to find g of 3, which is the square root of 3 plus 6. This simplifies to the square root of 9, which is 3. The output of 3 from g of x becomes the input into f of x, so now we must evaluate f of 3. We have 3 squared plus 1, which simplifies to 9 plus 1, which is 10. F of g of 3 is equal to 10. If you were to switch the order around, you will not necessarily get the same answer. Let's try g of f of 3. This is the same thing as g of f of 3. This means we must first evaluate the function f at the value 3, and then use the output from f as the input into g to find our final answer. Always start with the inside function, which in this case is f of 3. Plugging 3 into f of x, we get 3 squared plus 1, which simplifies to 9 plus 1, or 10. 10 now becomes our input for function g. We have g of 10, which is equal to the square root of 10 plus 6, which simplifies to the square root of 16, which is 4. G of f of 3 is equal to 4. Notice that f of g of 3 is not the same thing as g of f of 3, so the order of the composition of functions makes a difference. Sometimes we might want to have a general formula for the composition of two functions. Consider the functions f of x is equal to x minus 4 divided by x minus 3, and g of x is equal to 4x plus 7. We would like to find f of g of x, which is the general function for the composition of g inside f. This is the same thing as f of g of x, which just means anywhere you see an x in f of x, replace it with the entire function g of x. So we could also write this as f of 4x plus 7. Evaluating, we have 4x plus 7 minus 4 divided by 4x plus 7 minus 3. Simplifying our answer, we have 4x plus 3 divided by 4x plus 4, which is the general form of the composition of f of g of x. The domain of this function includes all values such that the denominator is not equal to 0. We can find the domain by setting the denominator of 4x plus 4 equal to 0. Subtracting 4 from both sides, we have 4x is equal to negative 4. Dividing both sides by positive 4, we have x is equal to negative 1. The domain includes all values such that x is not equal to negative 1. Or in interval notation, we have negative infinity all the way up to negative 1, union negative 1 up to infinity. Let's try another problem. Say we have f of x is equal to x squared plus 3, and g of x is equal to the square root of x minus 2, and we would like to find f of g of x, which is the same thing as f of g of x. This means look at your f of x function, and anywhere you see an x, replace it with g of x, which in this case is the square root of x minus 2. So this could all be rewritten as f of the square root of x minus 2. Evaluating, we have the square root of x minus 2 squared plus 3. The square cancels out the square root, and we have x minus 2 plus 3. This simplifies to x plus 1, which is our final answer. Now the tricky thing with this one is determining the domain. You might look at x plus 1 and wrongly think that the domain is all real numbers. To determine the domain of a composition function, you should really look at the unsimplified version of the composition. Looking back at the square root of x minus 2 squared plus 3, we had a square root, which means that the inside of the square root should be a value that is greater than or equal to 0. If x minus 2 is greater than or equal to 0, we have x is greater than or equal to 2. So the domain of our composition is actually x is greater than or equal to 2, or in interval notation, bracket 2, comma, infinity, close parentheses. Let's say that we already have the function h of x is equal to 7 minus 6x squared, which is the composition of two functions. We want to find two functions f and g such that f of g of x is equal to h of x, and one of the functions cannot be the identity function x. The way I think about a problem like this is to consider the bigger, broader function that encompasses the whole problem, which will be function f, and then separately think about the more specific function on the inside of something, that will be the function g. The overarching form of the function h of x is something in parentheses squared. That means f of x must be equal to x squared. G of x is the inside, the specifics of the function that is being squared. That means g of x must be equal to 7 minus 6x. If you aren't sure, you can form the composition of f of g of x and see if you get h of x back. F of g of x is equal to f of g of x, which is f of 7 minus 6x. This means go to the function f and plug in 7 minus 6x anywhere you see an x. We have 7 minus 6x squared, which is the same thing as h of x, verifying that we have completed the problem correctly. If you are really creative, there are sometimes other possible solutions, but the one I've shown you here is the most obvious one. Let's try one more problem. We have h of x is equal to 5 times the cube root of x plus 1, and we want to find two functions whose composition is equal to h of x. And let's say that we can't let one of the functions equal x, sometimes called the identity function. So what can we use for f of x and g of x? You might have to just guess and check to see if something works. As I said in the previous example, you oftentimes want to think of f as some bigger overarching function in the problem. Here we have some big mess of something, 5 cube root of x, that we must add 1 to. The overarching function is just something plus 1. So let's let f of x equal x plus 1. The more specific part of the function is 5 times the cube root of x. So let's let g of x equal 5 times the cube root of x. Let's check to see if it worked. F of g of x is equal to f of g of x, which is f of 5 times the cube root of x. F of 5 times the cube root of x is 5 times the cube root of x plus 1, which matches h of x, verifying that we have found a solution. Alright, my friends, that wraps up our video relating to compositions of functions.